Correlation and Regression, chapters 3 and 4. There it is. We went over this. Read the chapter. We talked about the cost of reproduction in male fruit flies, right? We talked about this in the lecture. This is just review, showing it how to show it on a graph with different colors. We talked about putting the scatter plot on axes that don't distort the data, the meaning of the data. We didn't talk that much about the calculations of it because we always use computers to do that. Facts about correlation, 1, 2, 3, 4. What is Pearson R? Indicates positive R is positive association, negative R is negative association. Correlation is always -1 to 1, right? Values of R near 0 indicate a very weak linear relationship. The strength of the linear relationship increases as R moves away from 0 toward either -1 or 1. It's all right here in the textbook. And we looked at this very same graph. We looked at pictures of what a graph would look like if the correlation was 0, up to a correlation of 0.99, very strong correlation, so you can see how that looks. And we've got summaries here that explain everything. Apply your knowledge. I recommend looking through all of these. Very good examples. There's some pretty interesting information in the book too. I learned a lot by reading it, things that I thought were kind of cool. And then we come down to the check your skills section. And again, these are pretty familiar to us because we've seen some of this before. We've seen these before, right? I've presented you with these examples in the past. Let's say you have data for many individuals on their walking speed and their heart rate from a 10-minute walk. When you make a scatter plot, the explanatory variable on the x-axis is, this was actually a quiz question earlier, wasn't it? Right? So what's going to be on the x-axis here? Well, what's probably affecting what? Is walking speed going to be x? Is it heart rate, or it just doesn't matter?
A.
A, right? Yeah, because walking speed probably affects heart rate and not the other way around. Okay, great, thank you. So you have data from many individuals on their walking speed and their heart rate after a 10-minute walk. You expect to see what? A positive association, very little association, or a negative association?
A.
A, right? You expect a positive association. Heart rate increases as people walk more or walk faster. Okay, same thing. So you guys, I think you're going to do great on this part. I think this part's going to be really easy for you. What are all the values that a correlation R can possibly take? Well, we just saw that. It's between -1 and 1, right? These are all the questions. And you guys are welcome again to look up the answers, help each other, work together, quiz each other on the answers. So if we go down to regression, again, we covered in regression the idea of the least squares regression line, using technology, outliers and influential observations, cautions about correlation and regression, and how association does not imply causation. And again, if we go down to this section here and check your skills, we get all the questions here that might be on the test, or questions very like this. Figure 4.8, where's figure 4.8? There it is, figure 4.8. You all know how to read graphs by now, right? Figure 4.8 is a scatter plot of tree frog mating call frequency in notes per second against outside temperature in degrees Celsius for 16 American bird voice tree frogs. The line is the least squares regression line for this predicting call frequency from temperature. If another frog of this species initiates a mating call when the outside temperature is 24 degrees Celsius, you predict the call frequency to be close to, and we've seen this very one before, haven't we? So if we had another frog on this graph that was calling at a temperature of 24 degrees, you'd go up here and you'd say, okay, there's 24. What's the frequency of the call going to be? It's going to be somewhere around here, right? If you drew a line up from 24, that's the temperature, and then you drew it over to the y-axis, it's going to be like 6.5, somewhere between 6 and 7, right? And so if we were looking at the multiple choice, it says it's going to be close to either 5, 7, or 9. Right? It's going to be close to 7. And the slope of the line is close to negative 0.5, 0, or 0.5. Now, we don't have the slope. Nobody gave us the slope. But if you think about it, remember that a slope of 0 is a flat line. It's a horizontal line. And if it was a negative slope, it would be going down and to the right. So if it's a positive slope, it has to be, and it's going up, it's got to be not 0, and it's got to be positive, right? So you already know the answer to this question without even seeing the regression output. You would be able to look at that figure and you'd be able to say, oh, okay, I know what the slope would have to be this one. Oops, have to be this one, right? You measure the weight in grams and the tail length in millimeters of a group of mice. The equation for the least squares line for predicting tail length from weight is, and we've done this a bunch, predicted tail length is equal to 20, which is the intercept, plus 3, which is the slope, times whatever your weight value is. Knowing that, you would say how much on average does tail length increase for each additional gram of weight?
3.
Right, 3. It increases by 3 millimeters for each additional gram of weight because that's the slope. According to the regression line, same one, the predicted tail length for a mouse weighing 18 grams is, so you just say 18 times 3 plus 20. 74. Yeah, I mean, without actually doing the math, that sounds about right. It's got to be something like that.
Yeah, it'd be 74.
74. Okay, great. You will be allowed to have a calculator, but bring a calculator, not your phone. Okay? Bring a calculator, not your phone. There will also be a calculator, of course, on the computer, but you won't be allowed to access the internet. But I think there's a calculator app on everybody's computer, right? Right? Everyone's got a calculator app? I've got a calculator app on my computer. If I go here, calculator, there's a calculator. You can do everything that you need to do. That's allowed, right? Right, Michelle?
Yeah.
Yeah, it's allowed in tests. But otherwise, just bring a calculator. But you can't use your phone. You have to put your phones away. This is how you study.
Yes, indeed. Mm-hmm.
You got it? Okay, good. You feel like you're going to ace this test?
Yeah.
Yeah.
For sure. You don't even go here.
Just, I know some of you are going to have to cram. If you didn't read the chapters all along, you're going to have to cram. If you kept up with reading the chapters, it'll be easy, but you can do it. Zach, what's your question?
Real quick, I got chapter 18, 24, 3. What other questions? What are the chapters?
Oh, okay, the chapters, I sent you an email that had a list of all the chapters.
Last week, but not today, it was.
It was a couple days ago.
And those, you are, I'll let you know, definitely be able to test.
Sorry?
In the email. All those chapters will be able to test
All the chapters will be on the test.
on this table that you made.
Yes, that's correct.
Um,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 chapters. The magic number. Any other questions? You do have to be in person. You do have to be in person for this test because otherwise we can't really ensure that it's you doing it. Could be anybody. Could be a robot. I would totally get a robot to do my test. I bet Eddie could do it. She's been to all the classes. She knows this stuff. She always sleeps through class though. Yes, ma'am. You want to meet? Yes. Yeah. Happy dance. That's what I like to see. We got there. We survived. I survived statistics.